Hi guys, Subhodeep again, and today I'm going to teach you loops. So loops are very interesting and a bit complex as well, but you will find it interesting, and as well as it is really useful for any programming language in the whole world. Okay, every language requires loops. These are very important. Okay, and why did I choose loops? Because you would tell me that last time you guys voted for functions. So why did I choose loops over functions? The reason is that I initially thought that I would teach you function so that I can teach you recursion. Okay, I had also mentioned that after loops I'll be teaching recursion. But then I had this thought that recursions are not that important, especially in Python, because those who come from C and C++ or Java background, they will know what a recursion is. And you know how difficult or complex it is, okay, the concept of recursion. And above that, Python has a limitation. Python does not allow recursion more than 1000 times. So if you do that recursion thing above 1000 times, it will give you error, recursion error. So this is for C and C++ Java programmers who have actually written code in those languages previously. They must know this, okay? Because in C, C++, Java there are no limitations as far as I know, but Python has them. So that's why I thought, okay, it's not that important, especially in Python, because Python has its own limits. So and moreover, you are not going to use recursions anyway. In most of the time, you are not going to use recursions because there are things which recursions can't do. Recursions can't do, and I'll show you recursion. But just an example, you are saying print hello world, and inside hello world you are doing again print something. So that is a recursion. Print is calling print itself. So it's a pretty complex topic. I'll move on to that later once I teach Python, functions, because in functions I'll show you how to use loops, conditionals, all those, and then finally I'll come to recursions. So let's begin today's topic. So today's topic is loops. And what are loops? Loops are basically doing same set of actions repeatedly. Same set of actions repeatedly. Uh, there is a singing competition out there, and for every performance you are clapping your hands, claps. You're applauding. Okay, so what is the action here? The action is clapping. See, every time 1 2 3 4, I know every single time I do 1 2 3 4, and how many times I'll do this, the number of times the performance happens. So what is the logic here? Until all the performance gets over, until all the singers are done singing, until the program is over, we'll clap for every performance. Every time a performance happens, a performance completes, you will clap. So clapping is the action. Repetition, condition, there is always a condition. Condition is what? That you will clap for every performance in the event, and you will not clap once you know the whole function gets over. Okay, the whole convocation gets over or something like that, program gets over. That is the condition. You are repeating this, right? You are repeating the same thing again and again and again. So this is loop. This is a real life example. Okay, so let's say have you ever got punishment from teachers? I guess yes, because every one kid has got them, including me. So when I was a kid, my teacher used to tell me, right, I won't come late again 100 times. So I guess most of you has faced the same punishment. It was fun. Okay, it was fun. I used to take 3 or 4 pens together, and I used to do this like, okay, I won't come late again. So basically, there were 4 pens, and 4 lines were completed for one time. Okay, that is another trick. But again, another concept is that I am using loop again inside loop. So what is the loop here? The loop is write 100 times. Okay, write 100 times. For 100 times I am writing 4 times as well. So teacher told me to repeat a task. What is the task? Write I won't come late again. This is the task for 100 times. And what I am doing is I am simplifying my task by writing by using 4 pens at a time, so that I can complete 4 lines, one line. So if I divide 100 by 4, I can complete it in a much shorter time as compared to 100. So basically I'm using loop inside loop. So that is a complex concept, I'll come to that later, but this is just another example. Write 100 lines of write 100 lines, I won't come again, I won't come late again. So this is a loop. You are doing the same action again and again and again for 100 times. For 100 times. What is the condition here? Condition is until 100 lines are completed, keep writing. This is one way of saying this. And another way is write for 100 lines, as simple as that. Your teacher has told you to write 100 lines. That is one way of thinking. And another way is write until 100 lines are completed. There are two ways of thinking this. And this, the first way, the teacher basically tells you write 100 lines. This is for loop. And the second line, the second option, write until 100 lines are completed. There is a condition. So this is a while loop. Okay, I'll come to those also later. So these are the examples. So, and some other examples may include, have you ever seen, there is a box full of balls, and you are basically taking each ball and throwing it again and again. So how many times you will throw those balls? Until all of the balls are empty in the box, right? You are doing this. So for every ball you are taking it, throwing it, taking it, throw it. What is the function? What is the task here? Take the ball, throw it. So this is the same thing you are repeating again and again. So this is the action, and you are doing this for a number of times until the box is empty. This is the condition. Until the box is empty, take one ball, throw it. Take one ball, throw it. This is the action. Condition is until the box is empty. Okay. So that was it. And let's come to some more mathematical examples so that you can understand easily. So if I tell you, give me a number, give me any number you like. You say, sir, 100 is the number. So if I tell you from 0 add to 100, will you do 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus, you have to do like this, okay? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus, and you keep on doing this till 100. So this will be lengthy. If I tell you, okay, just add, okay, you tell me, sir, the number is 3. So I tell you, add all the numbers from 0 to your choice of number. That is 3 for in this case. So 0 plus 1 plus 2 plus 3. So let's ignore 0. 1 plus 2, 3 plus 3, 6. Okay, 3 plus 3, 6. So that's how you count. But in case of a big number, let's say 1 lakh. Let's say 1 lakh. Are you gonna do the same way you did like this? Okay, 0 to 1 lakh. Are you gonna do 1 plus 2 plus 3 plus 4? It will take an eternity. Okay, it will take a long time. It will take a long time. So can you convert this into loop? Think. I'll tell you. I give you 5 seconds. Think. Can you convert this action? Can you identify the common action here? Can you identify the same action here? Think about 5 seconds. So I give you 5 seconds. Think. 1, 2, 3, 4, 5. Okay, so let me tell you. Yes, the action is repeated. And what is the repeated action? What is the repeated action? The repeated action is, let's say you are adding all the numbers starting from 1 to your favorable number, let's say 10. You are adding all the numbers from 1 to 10. So what are you doing? 1 plus 2 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, like that you are going, right? So what is the logic behind this? You are starting from 1 and you are going to 10. Starting from 1 going to 10, and the numbers are increasing one by one. 1 plus 1 is what? 2. What was the previous value? 1. So the initial value is 1. You add 1 to it, it becomes 2. These are both different numbers. This is the new number after adding 1, and this is the number before adding 1. This is the number after adding 1. This is the number before adding 1. Add them. What is the result you get? 2 plus 1, 3. Now add 1 to it. What is the old number? 3. What is the new number? 4. Add them. Like that you continue. So what is the common action here? You take a number. You basically take a number. You add 1 to it. And the new number, what you get after adding the 1, you add it to the previous value, which was 1. Because if I take 1, then add 1 to it, it becomes 2. So 2 is the new number. What was the old number? 1. So 2 plus 1, 3. And you keep on doing the same things until you reach 10. Until you reach 10. And you get the answer. That's how you do. That's how you work in loops. It is a mathematical example. Okay. So if I tell you, okay, let me demonstrate, or let me actually tell you what are the things you can do with loops. There are thousands and millions and lakhs of things which are done by loops. Some of the realistic examples are websites. Have you ever seen a very fancy website having all those animations? There are lights blinking off, on, off, on, off, on. Have you ever seen that? That is a loop. Loop used in another language. It is JavaScript basically. So this blinks, continuously blinks. Okay, this keeps on blinking for a particular time, or maybe forever. Okay, you must have seen these. So these are loops. It is continuously the same thing is happening. What is the action here? Turn it on, turn it off. Turn it on, turn it off. So this is a repeatable action, and doing the same action multiple times, that means there is a loop. Okay. So there are two kinds of loop. While loop and for loop. And this here, it is a while loop. So what I have written is quite funny, and you guys might find it interesting. So what I have said is eat, sleep, code and repeat. Eat, sleep, code, repeat, eat, sleep, code, repeat, and this circle continues. Okay. So this is the diagrammatic format, and this is the code format. This is the code format. What is the format here? While true. I'll explain all of these later on. Basically, while true means that this will continue forever. Forever. While true, eat, sleep, code. Again it will repeat. Eat, sleep, code. Again it will repeat. Eat, sleep, code. And this will continue forever, because there is no condition over here that you will stop. You are not gonna stop. You are not gonna stop. And remember about conditions. Like if else, if the condition was true, it would get executed. It would get executed. Okay. So here the condition is true. It will get executed forever, because this won't change. This true won't change. You have written true, it will keep on executing forever. That's why you will eat and sleep and code, and you will keep on doing this. And as a programmer, you will obviously keep on doing this. So let's see some basic examples. Okay, I don't need VS Code. Yeah, and I think you guys also don't need VS Code. And another thing, by the way, this time the assignment will be quite different. I'll give you some simple questions to solve, because loops are already very complex, and I really don't want to add more complexity to it without clearing your basics. And how will the basics clear if I write code and you see the video? No. The basics will only be clear if you guys practice it on your own, and I'll be there to give you practice questions. I'll tell you to print these things, print all those things. Okay, I'll give a short demo. And all those things you will think by yourself, because I have taught you variables, I have taught you conditionals, so you should think. There are times when you will find it hard, but do not worry, because I am always there to give you solutions. But first you try it. My objective is to give you questions so that you can utilize your mind, because programming doesn't happen by watching videos. By watching videos, you are just only knowing how to use loops. What are loops? But by implementing it, you know where to use loops. And that is the single most important thing of programming. You must know where to use loops, where to use which type of loops, because there are different types of loops. There is while loop, there is for loops, as well as there is recursion. I'll come to that topic later, but still it is also a kind of loop. Okay, so without further delay, let's begin and let's write some code. Let's get our hands dirty. So let's begin. First I'll begin with, okay, before that I have colored this window. You can change this color as per your wish. In Windows there is a beautiful command called color 02. Can do this, and I can just make this pink, whatever. Okay, if you want I can give you the commands. Okay, so basically you can do color help. So as you can see, this is not important, just for your own fun, because there are times when working in terminals becomes quite tedious. So that's why I'm just, you know, advising you. As per your choice, you can change the color. So basically it says color attributes are specified by 2 hexadecimal digits. Okay, and you don't need to know what the hexadecimal digits are, at least not now. It is basically 0 1. It starts from 0 and it goes to 15. Okay, it goes to 15. So basically 0 1 2 3 4 5 6 7 8 9. A stands for 10, B stands for 11, C stands for 12, D stands for 13, 14, and finally 15. So after, for hexadecimal digits, there is no 10, 11, 12, 13, and 14, 15. Okay, it is A, B, C, D, E, F. So you can use this, and for every digit there is a color. So 0 is for black, 1 is for blue, 2 is for green, and all those colors. So the first digit corresponds to the background. That means this black color over here, it means 0. It means 0. And the second for the foreground, that means the color you are seeing, this pink color, that means I have used this one. Where is it? See, I've used this one. So that's how we change colors. So if I do color, let's say make the background black and make the foreground light blue, it changes the color. So that's how you change color in the terminal. You can also do like, okay, that way this will be a very ugly color, but still if you want you can do color, let's say C for background, that means light red, and light blue 9. Yuck, it sucks. Let's go back. Okay, it is better. Okay, so let's begin coding. Okay, Python, launch the Python interpreter. This is a slower method. You can use Py, whatever you like. Okay, so it has opened. Now you can just start coding. So what is before writing anything, what is the syntax? The syntax is quite this. While okay, before that let me give you an introduction. Yeah, first I'll start with while loops, because while loops are actually more simpler than for loops in Python. I'm talking about Python, so that's why I'm starting with while loops. While loops are much easier to use than for loops. I personally believe that, because it comes handier. And when you actually use other data structures like lists and tuples and dictionaries, maybe that time you will like for loops. But for mathematical operations and all those conditional tasks, basically you will have to use while, or it will be preferable to use while. There may be conditions where you can actually replace while loops with for loops, but it's best to make it a rule of thumb that for data structures use for loops, for printing patterns use for loops, and for doing operations based on conditions use while loops. So what are while loops? As I told you earlier, while loops are just as any other loop. That means repeating the same action again and again, but based on a condition. So if I tell you that print, let's say give a number, let's say 10. So print all the values starting from 10 to 0. I mean, you will reduce it. 10, then 9, then 8. You will basically down count. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You will do this. So you are doing minus, 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 minus. So what is the condition? You will stop. You will have to stop when the number is 0. If you do not stop, by the way, if you do not stop, it will keep on decreasing and the value will go -1, -2, -3, -4, -5 and it will keep on continuing. So you want to print 10 to 0 back count, and when it comes to 0, stop. Just stop. Okay, that's how you work with while loops. You provide a condition, and just like if else, if this, then do this. Remember conditions? So if this, what is this? This is a condition. If this condition is true, then execute it. Just like if else, in while loops, if and only if the condition is true, then only the things inside the loop will get executed. Now what is the syntax? In Python, syntax are very identical. In if else you have used if condition colon, press enter, you give a tab or space, and then you write the body, and you exit from the space, the block will get over. So everything in Python is a block. Remember this, if else block. And in C++, people use curly brackets. If you're from other coding backgrounds, C++ or Java like me, so you probably have used those curly brackets or curly braces. You must have used those. So in Python, there are no curly braces, there are no semicolons. Thank you, Python. I love you. This is the reason why I love you. And it saves the complexity. But again, in C++ languages, you know that if condition starts from here and it ends here, because bracket starts here, bracket ends here. But in Python, it is quite complex because you cannot see space. Can you? Okay, you can visually see, but can you measure? If I say I hit 3 spaces or 4 spaces, can you just tell by naked eyes that I have used 2 spaces or 3 spaces? No. Now if you, let's say in the first line you press 2 space, in the second line you use 3 spaces, it will give you a syntax error. So that's why Python is sometimes becomes complex while debugging. Debugging means you are correcting a particular error. So let me open a notepad so that, or even a Sublime Text basically, so that I can show you what the syntax of this looks like. And so basically this is the solution which I told you last time. Control Z. I hope you guys got the last time what I have said. So this is the condition. This is the while loop. While condition. Okay. Before actually doing, so this is how a while loop looks like. While you space, you use brackets, and inside these brackets, remember I told you to use brackets. These brackets are very important. Okay, while, write a condition, write anything, whatever condition, and write these down as I write this. Okay, write this in your copy or wherever you prefer. Colon, enter, press a tab, okay, press a tab and write what, action 1. Okay, and do not add all those, these are just comments. Okay, these are just comments, so do not add all these. I hope you guys know what a comment is, so I hope you won't do that. So you write action 1, you write action 2, you write action 3. Okay, this is the body of the while loop. Okay, and finally action 4. So let me give you a brief overview. This is where the while loop starts and this is where it ends. This thing is not a part of this thing. Why it is not? Because can you see I have given this tab over here. Every line there is a tab. There is a unified space. This is a unified space, sorry. This space over here. But there is no space. That means this thing is not a part of this thing. That means this thing is outside of this while loop. That means action 4 does not care about this condition. Action 4 will eventually get executed. Okay, that is the syntax for while loops. Okay, now another thing, if you say that control Z, if you say like this, let's say you have hit a tab. Okay, this was a tab, right? As you can see, this is a single tab. Now if you do like this, let's say go back and you press 1 2 3 4 5, this is wrong. This is wrong. Although it will see, as you can see, there are 4 dots. That means you have hit 4 spaces. But this thing, it is a tab. So these are not equal. If you give this and you say, okay, action 2, this is an error. This will produce an error. So you either use tabs or you use space, but don't mix them. If you think you are gonna use 4 spaces, press 1 2 3 4, action 1. Okay, 1 2 3 4, action 2, action 3. So now when I come back, can you see those 4 dots everywhere? Because for every line I have used 4 spaces, and that is correct. That is correct. But I never recommend using spaces in case of loops or whatever condition or whatever it is. I never recommend using these spaces because spaces will lead to error. You cannot understand. Okay, if I tell you, if I do not take the cursor there, can you tell me it is a tab or space? You can't. You can't, because you are not a machine. You can't. You may tell it is a tab, you may tell it is a space, but it is what it is. You might not know what it is. Okay? This is a space. This is not a tab. And even if you do like this, let's say you have used 4 spaces, but you just remove one, or you just added one, or you again remove 2. So this is wrong. This is wrong. This has to be vertical. This has to be vertical. As you can see, these 3 are parallel to each other. Can you see this? Same line, same line. So you have to maintain this. This is the basic syntax of a while loop. So let's start a while loop. So is 5 okay, is 6 more than 5? Is 6 more than 5? 5 more than 6. Okay, 5 less than, okay, 5 more than 6. False. 5 less than 6. 5 less than 6. True. Now, if I say while 5 less than 6, use a tab, print hello. This will never end. This will never end. The reason is 5 can never be, 5 is always less than 6, and this will always give you true. And while the condition is true, this will get executed forever. Forever, because this condition will always be true. It will never be false. Do you want to see the demonstration? Enter, hit enter. See, it keeps on going. It never stops. So if you want to stop this, press Ctrl C. Press Ctrl C. By using Ctrl C, you can stop an infinite loop. This is called an infinite loop. See, it never stopped. It never stopped. It started from here and it kept, printing. Why did this happen? Why did this happen? Because 5 less than 6. Obviously it is true. And while true, print hello. While true, this condition is true, right? See, 5 less than 6 is true. And as I told you, every time the condition is true, the action specified inside the loop will be executed. And this was always true. That's why it is being executed. It is as simple as that. Now let's clear the screen out. CLS. Oh shit! I'm inside Python interpreter. Okay. Anyways, leave it. So if I have to match the condition, let's say there is a number equals to 10. Favorite number. And my task is to add from 10 to, I'm sorry, without adding, just read back count from 10 to 0. That is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. How will I do this? While, and where do I have to stop? 0. While number not equals to 0. Not equals, this is the not symbol, okay? Not equals to symbol. Not equals to, that means if number is not 0, while number is not 0, use a tab, always use a tab, print number, oops, print number equals to number minus okay 1. So what this means is print number, that means print whatever the number is currently, then basically just subtract 1 from the number. And why have I written number equals to number minus 1? Because number equals to, that means this is the current number, equals to previous number, that means the number it was here, minus 1, and this is a new number. Okay, so how this executes? Okay, first let me print this out, you will understand better. As you can see, okay, the 0 never came. Okay, it's okay. Anyways, yeah, so what happened actually? While number not equals to 0, so the loop started. Number, what is the value of number currently? 10. Now is 10, number is 10. 10 not equals to 0? Is 10 not equals to 0? True. Obviously true. Okay. Because 10 is not equal to 0. Can you say 10 is 0? No. Executes. It prints 10. And then it just subtracts 1 from 10. That means 9. Is 9 not equal to 0? True. Because 9 is not 0. Okay. Print number. That means it prints 9. Number equals to number minus 1. It again subtracts 1 from 9. It becomes 8. Is 8 not equal to 0? That means is 8 not equal to 0? So yeah, definitely, because 8 is not 0. Print 8. Subtract 1 from 8. It becomes 7. Okay, it becomes 7. Is 7 not equal to 0? True, because 7 is not 0. Print 7. 7 minus 1, 6. And this continues till 1. And why does it stop here? Because once it prints this number 1, okay, let's start 2. So let's say the number is currently 2. 2 not equals to 0? True. So it prints 2. It prints 2. Now it subtracts 1 from 2. What is? It is 1. So is 1 not equal to 0? Definitely, because 1 is not 0. Clearly. So print 1. Print 1. So 1 is done. Now again subtract 1 from 1. Now if you subtract 1 from 1, what is the result? 0. Now is 0 not equal to 0? False. Because 0 is 0. 0 is equal to 0. 0 not equal to 0 is false. Why? 0 not equals to 0. False, as you can see. But if you do 10 not equals to 0, this will give you true. This will give you true. Because 10 is clearly not 0. But 0 is 0. So if you say 0 not equal to 0, it will give you false, because these two are same. That's why if you use 0 equals to 0, oops, 0, okay, you have to use a double equals. 0 equal to 0, it will give you true, because 0 is 0. But if you use 0 not equals to 0, oops, control C. Yeah, where was I? Yeah, if you say 0 false. As you can see, it will give you false, but in case of 0 equal to 0, it will give you true. So that's how while loop works.